Okay, so here are your 3-4 notes. For your objectives, for your learning targets for 3-4, you want to be able to apply the triangle sum theorem to find missing angle measures, classify triangles based on the angle measures and number of sides, and lastly, apply the exterior angle theorem to find missing angle measures. Alright, so we'll get our vocabulary done. Equiangular, equiangular just means that the angles are the same, are congruent. So normally what they're referring to there is a polygon. So if you had a pentagon, my pentagon is not going to be very pretty, and I'm sorry. All of these angles would be the same. Okay. Acute is just less than 90 degrees. Right, like a cute little puppy. It's smaller than 90, so I don't know, let's say that that's 70. If they're using that in a triangle, which they will here, it means that all of these angles will be less than 90. Okay? Your next one is a right triangle. A right angle and a right triangle, we could think of either. Either way, it's going to be 90 degrees. If you're doing a right angle, ooh, that's ugly. You want it to be straight up and down, straight left and right. And you could either use a box to signify that it's a right angle, or you could also just do the arc measure and a 90 degree. Either way is right. To do a right triangle, you would also need a box or the 90 degree measure. And only one of your angles is going to be 90 for a right triangle. If you think about that, if you've already used 90 in your triangle, you only have 90 left to work with, 90 degrees left to work with. These both can't be 90, right? So if you have one right angle, that's all you could have. Obtuse is more than 90. So an obtuse angle could look something like that. If you can't go above 180, then we get into, we kind of would measure it the other way. When you measure an angle, it's always the smallest, at least until you get into some Algebra 2 things. So for right now, it's always the smallest distance. I don't know, so let's say that maybe 120. An obtuse triangle is the same idea, only it's a triangle instead of just an angle. So here would be my 120. And again, you can only have one angle measuring 120. Excuse me, more than 90. Equilateral. So equa means equal. Lateral is talking about kind of lines or sides. So that's exactly what it means. It means equal or congruent side lengths. So we'll go back to that pentagon I tried to draw earlier. And instead of having all the angles equal this time, we'll just mark all of the sides congruent. All of the side measures are equal. An isosceles is a triangle with two or more equal sides. If we're talking about a triangle, more would just be 3, right? So technically, when you're thinking of an isosceles triangle, this side and this side would be the same. Scalene, it's a triangle with all sides having different measures. Kind of draw a crazy triangle. Everything would be different. An exterior angle of a polygon is when you extend a side, and the adjacent side. I don't like those words. I'm going to draw you a picture. This is what I mean. Let's go back to that pentagon that evidently I really enjoy. So here's my pentagon. Not a very pretty pentagon. Your exterior angle is when you take one side of that pentagon, so let's take this one right here, and you keep drawing. And then the angle created by that side that you extended and the side that's right beside it. So what I mean by that is right here. That's an exterior angle. That's an exterior angle. That's an exterior angle, right? And you would just continue creating these angles. Okay? So 5 exterior angles because there are 5 sides that I've extended. Remote interior is our last one. I'll give you a picture for this. So it's when you're talking about an exterior angle. So let's use this for our exterior. Sorry. Here and here would be your remote interior angles. There and there. So those are remote. Remote is far away, right? Interior is inside. So remote interior angles. Okay. So the triangle angle sum theorem is just telling you that all three angles of a triangle have to add up to 180. So down here, if you're going to apply that, I know that there are actually technically 3 triangles here. There's this one on the left, one on the right, and then a large triangle making up the whole thing. There's lots of different ways to find these angles. If it was me and I was trying to do this, I would look at this triangle on the left and know that all of those angles should add up to 180. So I would say 180, and I would subtract 39, and I would subtract 65. If you were to do that math, you would get a 76. So this angle right here, x, the measure of angle x is 76. If it was me and I was trying to find y, I would use supplementary angles here, right? X and y make up this line on the bottom. So I would say 180, subtract x, or subtract 76, would get me 104. So the measure of angle y would be 104. And then finally z. And you could find z by either looking at this small triangle on the right, because we've now solved for y, or if you prefer, you can look at the large triangle and add 39 and 21 to get this angle here, and 65. So since we're talking about triangles, I'll do that. So there's 180 degrees in a triangle. I have 65. I need to subtract. I also have 39 and 21. Well, 39 and 21 will get me 60. So I'll just take away 60. So the measure of angle Z will be 125, be 55 here. Okay, so there are my 3, and they just wanted X and Y, sorry, I guess we're overachievers. If we look below though, they're going to ask for the measure of angle Z, and they want it found in 2 different ways. So we just used one way, right? We talked about this large triangle. Another way we could do it would be the small triangle. So my second way down here is going to be to look at that small triangle on the far right. So 180, still in that small triangle, no matter what size the triangle is, it's always 180. Minus y, which would be 104. Solved that before. And I also want to take away 21, because that's that top angle there. So 125 minus 180 would again be 55, which is good, right? The measure of angle Z should be the same no matter how I go about finding it. Alright, and moving on to the next. Alright, if you are going to classify triangles, I want you to classify this one by its sides and angles, right? Draw and mark a triangle to fit each description below. If I was going to do this one, I know that these two are equivalent, so it would be isosceles. And looking at it, I'm going to assume, which you should never do, and I'm going to here, I should have given you angle measures, but those are all less than 90, so it's an acute isosceles triangle. For your quick check, they want you to draw and mark a triangle to fit each description. If no triangle can be drawn by not possible, and explain why. So acute scalene, acute means all of my angles are less than 90. Scalene means that they're all going to be kind of crazy, not going to work. So everything is acute. Well, it's an ugly picture. Let's see if I can draw a better one. You want little sides and kind of little angles, right? I want to say this one is different than this one, which is different than this one, and all of those angles should be different measures. When isosceles right, I'm going to make it larger so you can see what's going on. I would need a right angle. It's going to be isosceles. The two things that would have to be equivalent would be the ones making up the right angle. So I'll just connect those. Obtuse, equiangular. So obtuse means that one of them would have to be more than 90. But then if they're asking for equiangular, they would all have to be equal. So let's say 91, 91, and 91 for my three angles in a triangle. There's no way that that's possible. So this is not possible. And I'm just going to say a triangle is supposed to equal 180 degrees. Right? We kind of just talked through why that would not work. Alright, moving on. The exterior angle theorem just lets you know that if you have an exterior angle, the remote interior angles would be congruent to that. Here's a proof of why. Let's say that this angle right here, let's say it's 50. If you wanted to get angle 1, do you agree to find angle 1? You would add it to the 50 and come up with 180. The same is true for angle 2 and angle 3. So if this and this make up a line, if the 50 and the 1 make up a line, and a line is 180, and 2, 3, and 50 make up a triangle, and a triangle is 180, the measure of angle 1 must be the same as 2 plus 3, since they're both going to equal 180 by just adding 50 to them. So here, if they want me to find the measure of angle 1, I can just add up 40 and 30. So the measure of angle 1 is 70. And yes, there are definitely other ways you could find that. You could find this angle, take it away from 180, but it'll just be kind of doing the same math twice. Here, if that's 113 as an exterior, my exterior angle of 113 should be equal to the sum of my remote interior. So subtract 70 from both sides. So the measure of angle 2 will be 43. Okay? You can try the quick check. Alright, so for the quick check, two angles of a triangle measure 45. Find the measure of an exterior angle at each vertex. So if two angles of a triangle are 45, there and there, they add up to 90, so I know that the other one will be 90. I also know that if I'm talking about exterior angles at each vertex, right, I can kind of extend these. Here, I would just have to add up the 45 and the 90. And we get 135. So that means that this right here must be 135. You could also just say 180 minus the 45, either way. This would also be 135, and this last one would be 90. So I'd have 135 for that other exterior, and 90 right here. I would just need to either go 180 minus 90, or 45 and 45 is 90, so that must be 90. Okay, I believe this is your last example for this set of notes. It is. So they've created this triangle right here in this lovely chair. They have an exterior angle over here. They're saying the lounge chair has different settings that change the angles formed by its parts. Suppose the measure of angle 2, I'm going to redraw this. Oh my gosh, I'm going to try and redraw this. Measure of angle 2 is 32, so this is 32. And the measure of angle 3 is 81. Find the measure of angle 1, the angle formed by the back of the chair and the armrest. So here, it's in a triangle, so I have 180, and I'm going to subtract 32, I'm going to subtract 81. If I do that, I'll get 113 degrees. So the measure of angle 1 is 113 degrees. That was very crooked, I'm sorry. Okay. So work on your quick check. Okay, for the quick check, it says change the setting on the lounge chair. So I'm going to draw another picture. So the measure of angle 2 is 33. Measure of 3 is 97, so this would need to be opened much more. Find the new measure of angle 1, so right here. So again, I can go 180 minus those things. Minus 33, minus 97. Ooh, running out of room, and I'm sorry. So it'll be 50. Be the new measure of angle 1. And then, my final thing, explain how you can find the measure of angle 1 without using the exterior angle theorem. And if you think about it, we just did, right? We just used that triangle instead. So they're talking about, and I'm so sorry, This exterior angle. Look at your pictures closer, huh? That's angle 1. So if this was angle 1, right, was what I just figured out, this right here would be 50. I'm so sorry, you guys. The measure of angle 1 where they have it is up here. And I could just add 33 and 97. That would just be 130. So this angle 1, which I totally messed up your notes, I'm sorry, is 130, because I would just add this and this, because those are remote interior angles. Another way to find it could be what we just did. If that's 50, I would then take away 50 from 180 to get angle 1. Okay, so I can either use the exterior angle theorem for a triangle, which we did here, or I can use supplementary angles. Okay? If you have questions on that, please let me know. I'm sorry that I messed up my picture for you. Independent work is going to be page 150, 2 through 22 evens, 23 through 28. Just like anything, if you have questions, let me know, please.